Good day, students. Welcome to mathgotserved.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 11 to 15 of the Algebra 2 Common Core New York Regents exam for June 2017. Alright, let's start with number 11. It reads, which binomial is a factor of x to the fourth minus 4x squared minus 4x plus 8? Alright, there are two methods we're going to be using to solve this problem today. Let's take a look at the first method, which is the faster method known as the factor theorem. Okay? You can do this using the factor theorem, you can do this using synthetic division, and you can also do long division. Alright, I'll do the two faster methods today. So what's the main idea behind the factor theorem? Well, if you have a binomial of the first degree, if x minus r is a factor of some polynomial, okay? If x minus r is a factor of, let's say, f of x, then what? Then the related zero of that polynomial factor, r, when you solve this by setting equal to 0, and if you plug it into the function, f of r will be equal to 0. Okay, so this is what the factor theorem is. Now, in this particular problem, let's identify our f of x. Our f of x is the dividend, okay? This function right here. So let's call it f of x. So let f of x be the dividend right here, x to the fourth minus 4x squared minus 4x plus 8. Alright, now what we're going to be doing is we're going to be finding the zeros of these options right here. We're going to plug it into this function. Whichever generates an output value of 0, that is the factor. Okay, alright, so let's go ahead and test the first one. For option 1, we have x minus 2, so the related 0 is what you get when you set this factor to 0. Okay, and then you simply add 2 to both sides, and your final answer, x, is going to be equal to 2. Now, is this a factor? All we just have to do is take this value and plug it into our polynomial function f of x. So f of 2 is going to be 2 to the fourth power minus 4 times 2 squared minus 4 times 2 plus 8. Okay, let's simplify this using the order of operations. We're going to do exponents first. So 2 to the fourth power is 16. Minus 4 times 2 squared is 4. 4 times 4 is 16. Minus 4 times 2 is 8 plus 8. And we have an output value of 0. So what does this mean? Since f of 2 is 0, it follows that x minus 2 is in fact a factor. Alright, so our answer is clearly option 1. Now, what would we do if we didn't get a 0 result? We simply move on to the next one, repeat the same procedure, and keep on going until we get a result of 0. Okay? Now, let's try another method. This is the synthetic division method, is the accelerated long division. So method 2 is the synthetic division method. Some students prefer this over the factor theorem because all you're doing here is just adding and multiplying. Okay? Alright, so what's the main idea here? The main idea here is that if you have a polynomial f of x and you divide it by a divisor x minus r, if you carry out this division, if f of x divided by x minus r has a remainder of 0, which is the last number after you carry out a synthetic division, has a remainder of 0, then what? Then x minus r is a factor. Okay? So all we are focusing on here is what's the remainder when we apply the synthetic division algorithm and finding the quotient of f of x divided by x minus r. Now let's go ahead and identify what f of x is. So f of x is x to the fourth minus 4x squared minus 4x plus 8. Now when you're doing synthetic division, you want to make sure that every polynomial term is present. Alright? So we have f of x equals x to the fourth. The fourth degree term is present. Not only should it be present, but it should be written in standard form or in descending order of the magnitude of the degrees. So the biggest degree is 4, so we want 4, 3, 2, 1, 0. Everything has to be present. You notice that the third degree term is absent here. So what do? We insert something called a placeholder. Okay, so plus 0x to the third, so don't forget that, very important, minus 4x squared minus 4x plus 8. Okay, so this is going to be divided by, for option 1, we're going to test x minus 2. This should work. Okay? Alright, so let's go ahead and set up our synthetic division bars. Now for our synthetic division bars, all we're extracting are the coefficients of our the dividend polynomial function. Okay? So there's a 1 here, so we have 1, and then we have the 0, and then negative 4, and then negative 4, and then positive 8. Now, what are we going to put on the outside of the synthetic division bar? What you do is you find the 0 of this divisor binomial. Okay? So to do that, what you do is you extract it and you set it to 0. Okay? And then you find the related 0, just as we did here before we carried out the factor theorem. Add 2 to both sides, and you have x equals 2. So that's the number that goes on the outside right here. Okay, so keep that in mind. That goes over here. Now let's carry out the synthetic division process. All you do is you add downwards, and you multiply across over and over again until you end up at the last position here. Now what's underneath 1? There's nothing there, so 0 represents nothing. And now we're going to carry out the procedure. Add down 1, multiply across, 2 times 1 is 2. Completed the first column. Repeat the same cycle again. Add down 2, multiply across, 4. Add down 0, multiply across. Add down, multiply across. Add down. Alright, so what do we have here? This term is your remainder value. Okay, so this is your remainder. And what we notice is that the remainder is equal to 0, so that follows that x minus 2 is a factor. So let's write down that remark. Since the remainder is 0, x minus 2 is a factor. Okay, of what? Of f of x. So that's another way you can do it. Alright, and then you can also use a long division, but that's a little bit long. Same process. You look at the remainder, see what the remainder is. If you get 0, that tells you that whatever you divided by is a factor. Alright, let's take a look at question number 12. It reads, given that sine squared theta plus cosine squared theta equals 1, that's the Pythagorean identity for trig functions, and sine theta is equal to negative root 2 over 5, what is a possible value of cosine theta? Alright, so let's go ahead and rewrite the identity. We have sine squared theta plus cosine squared theta equals 1. So all we're going to do is substitute in the value of sine into this equation, negative root 2 over 5. Okay. Upon substitution, the next move is to simply isolate the trig function cosine theta, and that will be a result. Alright? Okay, so let's go ahead and simplify this. Now, when you simplify this, you're going to square the negative, the root 2, and the 5 individually. When you square that, you end up with negative square is positive, so root 2 square is 2 over 5 square is 25 plus cosine square theta equals 1. Okay? And then you proceed to subtract 2 over 25 from both sides. And what do we have? We have cosine square theta is equal to 1. Let's write it as a fraction over 1 minus 2 over 25. Now, in order to add or subtract fractions, you need identical denominators. The LCD here is 25, so you times this by 25 at the top and the bottom. Okay, and then we have cosine square theta. Subtract the numerators, 25. Well, let's just write it again, 25 over 25 minus 2 over 25. Cosine square theta is equal to 23 over 25. To get theta isolated, what you do is you take the square root of, to get cosine theta isolated, take the square root of the left and the right. On the right side, we have a fraction. So we root the numerator and the denominator independently. Okay? Alright, so what does that give us? We have cosine theta. The square and the square root are inverses, so they basically cancel each other out. Equals, now whenever you take the square root of a square, you have to insert plus or minus. Root 23 divided by the square root of 25, which is 5. Alright, so two possible values for cosine theta, either plus root 23 over 5 or negative root 23 over 5. We can clearly see that the answer is option number 2. Alright, let's take a look at question 13. It reads, a student studying public policy created a model for the population of Detroit where the population decreased 25% over a decade. He used the model P equals 714 times 0.75 to the D, where P is the population in thousands, D decades after 2010. Another student, Suzanne, wants to use a model that would predict the population after Y years. Suzanne's model is best described by. So what we're doing here is we're carrying out a conversion in the unit of time. Okay, so what do we want to keep in mind? What you want to note is that to convert from, we're going from decades to years. Okay, so what you want to note is that to convert from years to decades, what do you do? To convert from years to decades, you divide by 10. Okay, so let's take a look at some examples to illustrate what this point is trying to convey. So let's say you have 10 years. How many decades is that? 10 years is equal to 10. You divide it by 10 to convert to decades, right? Divide by 10. 10 years is equal to 1 decade. Okay, let's take another example. How many decades is 100 years? You take 100 and you divide it by what? You divide it by 10. Okay, 100 divided by 10, you get a result of 10. 100 years is 10 decades. If you're going from decades to years, you multiply by 10 or you do the inverse. Now let's think algebraically here now. If you have Y years, how many decades is that? Exactly the same procedure. You take your year value and you divide it by 10. Okay, Y over 10 decades. So this is what is going to assist us in setting up the polynomial function. Not polynomial function, sorry, the exponential function for Suzanne's model. Okay, so let's go ahead and do it. We will start from the first model. the first model that was created is, let's write that down, is P equals 714 times 0.75 raised to the d power, where d is in decades. Now, to carry out the conversion, d decades can be converted into y over 10. So y years is the same thing as y over 10 decades. Okay, so we're going to replace this with y over 10 because that's the decades value. This is basically what d is equal to here. Okay? Alright, so let's carry out that substitution, and we are going to have P population equals 714 times 0.75. Now, instead of d decades, we're going to replace that with y over 10 years. Y over 10 years. Okay? Now, let's simplify this. If you notice that y is the only exponential value for your option, so let's get that isolated using properties of exponents. So we're going to separate this power here, okay? So we have p equals 714 times 0.75 raised to the 1 over 10 times y. Okay? So all I'm doing is reversing just the product. So if you have 1 over 10 times y, that's y over 10, right? So I'm just going backwards. Alright, just undoing the product. Now this enables me to use the properties of exponents, the reversal of the power of a power. So what you will have here is 714 times, on the inside you have 0.75 raised to the 1/10 power, and then that entire thing raised to the y power. So if you have a power raised to a power, what you do is you basically multiply the powers. So I'm just reversing that, okay? Alright, now let's simplify 0.75 raised to the 1/10 power. Alright, so let's enter that into our calculators. 0.75 raised to the 1/10 power. Make sure you put your 1/10 in parentheses, okay? And then you get 0.9716 to 4 decimal places. Alright, so this can be reduced to P equals 714. This entire expression on the inside becomes 0.9716 raised to the y power. We can clearly see that our answer is option number 3. Alright, let's take a look at question 14. It reads, the probability that Gary and Jane have a child with blue eyes is 0.25, and the probability that they have a child with blonde hair is 0.5. The probability that they have a child with both blue eyes and blonde hair is 0.125. Given this information, the events blue eyes and blonde hair are dependent, independent, mutually exclusive. Okay, so first things first, what we'll do is focus our attention on the first two parts. An event or a sequence of events could be dependent or independent. Okay, if it's not dependent, then it's independent. So what we're going to do here is first of all determine dependence or lack thereof, and then focus on mutual exclusivity. Okay, alright, so to determine if two events are dependent or independent, this is a formula that we're going to be using. Okay, so the formula for independent events is as follows. Two events are independent if probability, let's say events A and B, okay? probability of event A and B is equal to the probability of event A times the probability of event B. If this equation holds, then events A and B are independent. Okay, then events A and B are independent. So that's what we're going to be using for the first two parts. Alright, so first things first, let's go ahead and declare what our variables are in this particular scenario. So let's start with probability of a child having blue eyes. Okay, so probability of blue eyes, let's call that PBE. Okay, and that's 0.25 as you can see there. And then what is the probability of a child having blonde hair? Okay, of Gary and Jane's child having blonde hair. The probability we will express using the notation BH, and the probability is 0.5. Probability of having both, so probability of having blue eyes and blonde hair, we'll use the notation P of BE and BH. In this particular scenario, it's 0.125. Okay? So the question is, are these two events independent or not? So let's go ahead and test it out using this formula we just talked about here, but we're going to adapt it to this scenario. So if the probability of blue eyes and blue hair, that the child has both of them, is equal to the probability of blue eyes multiplied by the probability of blue hair. If this holds, then we have independence. Okay, BE and BH are independent, or else they are dependent. So let's go ahead and do the mathematics here. So probability of their child having both blue eyes and blonde hair is 0.125. So the question is this equal to what you get when you multiply these individual probabilities? Probability of blue eyes is 0.5, no, is 0.25, and then probability of blonde hair is 0.5. So when you multiply these two on the right side, what do you get? You get, let's work it out. So if you have 0.25 times 0.5, your answer is 0.125. So this is 0.125. Oh, they are equal. So what does that mean? This means that the events blue eyes and blonde hair are independent. Okay, so let's make that quick notation there. This implies that the two events are independent. The two events are independent. Okay, so we can cross off the first one, and option 1 is gone. Option 3 is gone. So now the question is, are these events independent only, or are they independent and mutually exclusive, which would be option 4. So let's focus our attention on mutual exclusivity. To get that part started, we will take a look at the formula to determine if two events are mutually exclusive. Alright, so the formula is as follows. So we have the formula for um, mutually exclusive events. So if the probability of an event A or B is equal to probability of A plus probability of B, then that follows that the events are mutually exclusive. Okay? If not, then they're not mutually exclusive. Okay, so another thing you want to note is that probability of A or B is equal to probability of A plus probability of B minus probability of A and B. Okay? Alright, so let's get started. We want to answer the question is, let's change the color, is probability of blue eyes or blonde hair, is it equal to probability of blue eyes plus the probability of blonde hair? If this is true, then the events are mutually exclusive. If not, then they're not. Okay, so let's start with the first part. So we're going to break it up. Okay, we'll do part 1 and then part 2, and then we'll equate them and see if they're equal to each other. So that's 1 and then that's 2. Alright, so let's start with 1. We want to find the probability of blue eyes or blonde hair. Alright, so let's do this. So what we're going to have is, we're going to use the formula right here. Probability of blue eyes or blonde hair is equal to probability of blue eyes, that's just like probability of A, plus probability of blonde hair minus the probability of blue eyes and blonde hair. Alright, let's substitute the numerical values. Probability of blue eyes is 0.25. Probability of blonde hair is 0.5. And then probability of blue eyes and blonde hair is 0.125. Alright, so when you do the computations, you end up with 0.625. Alright, so we're done with the first part. So we'll advance to part 2. So for part 2, the question is, what is the probability of blue eyes plus the probability of blonde hair? Okay, so for part 2, let's put it in green, we're going to find, what are we trying to find here? We're trying to find what's the value of probability of blue eyes plus the probability of blonde hair. Okay, so let's do it. So we have probability of blue eyes plus the probability of blonde hair. Probability of blue eyes is 0.25, and then add the probability of blonde hair, 0.5, and your answer is 0.75. Okay, so the question is, are they the same? And the answer is no. 0.625 is not equal to 0.75. Okay, so since the probability of blue eyes or blonde hair is not equal to the probability of blue eyes plus the probability of blonde hair, what does that follow? It follows that the events are not mutually exclusive. Okay, so the answer is option number 2. Okay, because 3 is a fail, 1 is a fail, and then we have option 2 as our final answer. Alright, let's take a look at question number 15. It reads, based on climate data that have been collected in Bar Harbor, Maine, the average monthly temperature in degrees Fahrenheit can be modeled by the equation B of x equals 23.914 sine 0.508 minus 2116 plus 55.300. The same governmental agency collected average monthly temperature data for Phoenix, Arizona, and found the temperature could be modeled by the equation P of x equals 20.238 sine 0.525x minus 2.148 plus 86.729. Question: which statement cannot be concluded based on the average monthly temperature models X months after starting data collection? Okay, so if you take a look at the options provided here, there are 4 keywords that you want to familiarize yourself with. I will give you a visual representation of these keywords, and then we'll apply it to the problem. Okay, so first thing you want to note is the variation of the temperature. This is just a fancy word for the range. What is the vertical span of the graph? That's what the temperature variation is, basically from the lows to the highs. Okay, so that's what that's asking for. And then we have midline, we have maximum, and we have minimum. Okay, so we're going to take a look at a sine function here because we're looking at sine. That's what we're provided with. And what are these terms if you were given a sine function? So let's give ourselves a visual of what they are, and I'll also go over how to compute each component. We're going to start by looking at the midline. Okay, so midline is basically the vertical shift of the sine function. So midline is how high did you shift it. That's your h value. Okay, so for this particular problem, this is going to be our midline. Let me change the color there. So this is our midline. And the midline is basically your h value. Okay, so this is your h value, and that's your h value. So that's basically what the midline is. All right. Next thing to note is the maximum and the minimum. Okay, that one is pretty straightforward. The maximum is the high point, and the minimum is a low point. Okay, so let's go ahead and indicate that real quick. So let's say change this. This is your maximum right here. The peak and the valley is your minimum, the low point. Okay, pretty straightforward. So let's go ahead and label them. So this is your maximum right here, your max, and this is your min. Okay, now how do you get from your max to your min? Or how do you go? Well, the distance from the max to the min is your variation. Okay, but before we look at that, if you're going from the midline to the maximum or from the midline to the minimum, what you do is you add or subtract the amplitude from the midline. Okay, so if you're going from the midline to your maximum, what you're doing is you're taking the amplitude value and you're adding it to the midline. That takes you to your maximum. Okay, and then if you're looking for your minimum value, you're starting from your midline and you are subtracting the amplitude, so that will take you to your minimum. Okay, so what am I saying here? what I'm basically saying is that your maximum is going to be computed by finding the sum of the h value and your amplitude a. Okay, the amplitude value is basically what comes before your trig function, the coefficient of your trig function. So that's your maximum, and your minimum is basically h minus the amplitude. Okay, all right. The variation or the range is the vertical span of your graph. What's the length from the max to the min? That's your range or variation. Okay, how do you compute that? Is pretty straightforward. Your variation or range is simply your max minus your min. You just subtract your min from your max and you get your range. Alright, so these are the 4 different things we're going to be finding for these two functions, and then we'll see which one is accurate. Okay, those ones will be eliminated. The one that's inaccurate will be the correct answer, because we're looking for which statement cannot be concluded. So which of these is false based on our determination of the components of these two models. Okay, so I have two graphical representations of the two functions here, just to give you a visual understanding of what we're talking about, and then we're gonna go ahead and compute them individually. Okay, all right, let's start with the first model, the one from Maine, the Bar Harbor function. So that one is b of x equals 23.914 sine 0.508 x minus 2.116 plus 55.300. Alright, so for this one, we're looking at the a value, which is the amplitude, and we're also looking at the h value. Okay, those are our main players here. So for b of x, the amplitude is basically the absolute value of the coefficient of the sine function, which is 23.914. The h value is what you're adding on to the sine component, which is 55.300. Alright, so now we have all the tools that we need to compute the max, min, midline, and variation. Let's start with the maximum. The maximum is basically h, 55.300, plus your midline. So your h plus your amplitude. Your amplitude is 23.914. If you compute the sum, you're going to get 79.214. And then the midline is basically your h value, which is 55.3. These are all y values, by the way. Okay, and then your minimum is the midline, 55.3 minus 20 minus the amplitude, minus 23.914, which comes out to 31.386. And then your variation or range, same thing. Your variation is basically your max minus your min. Okay, so your max is 79.214 minus your min, which is 31.386. You have a range of 47.828. Alright, so what on earth do all these values mean graphically? So let's take a look at the graph. So this one, the first one is our b of x function. Okay, so this is what we have just found. The high point of this graph is your maximum. The peak, if you trace it to your y-axis right there, that's your high point. This is your midline, and this is your minimum. and then the span from the top to the bottom is your variation or range. Okay, so let's go ahead and put in the values so you can see what I'm talking about. This is a max, and the max is 79.214. The midline is 55.3, and the minimum is 31.386. So all we're doing is adding and subtracting the amplitude, okay? And then the span from here to here is your variation. You just subtract that. All right, now let's take a look at the second function, p of x, from Phoenix, Arizona. Same process. Let's write down the function first. So partition my workspace so we don't get things mixed up. P of x coming up. So p of x is 20.238 sine 0.525x minus 2.148 plus, run out of space here, plus 86.729. So 86.729. Okay, so there you go. Now let's go ahead and find the relevant components. Start with the amplitude. The amplitude here is 20.238. Absolute value of the coefficient of the sine function. Okay, so that's 20.238. Our h value, the vertical shift, is your h, which is 86.729. All right, let's start with the maximum. The maximum is your midline plus your amplitude, 0.238. If you add those up, you end up with 106.967. Your midline is your h value, which is just 86.729. As indicated earlier, these are all y values. Your minimum is your midline, 86.729, minus your amplitude, which gives us an output of 66.491. And then lastly is the variation, also known as your range. For the Phoenix function, the variation is the difference between the maximum and the minimum. Okay? And then in that case, we're gonna, if you subtract the two, you get 40.476. Alright, now we have all the information that we need. Let's go ahead and answer the question. Alright, so first one, it says the variation of b of x is more than p of x. So let's look at the variation of b of x. 47, variation of p of x is 40. So that statement is true. As you can see, 47 is bigger than 40. So first statement is true. Next one, midline of b of x is lower than midline of p of x. Let's see, midline of b of x is 55, midline of p of x is 86. That is true also. Next one, maximum of b of x is 79 degrees Fahrenheit when you round it up. Let's see, maximum is 79 when you round it up. That is correct. So the answer should be option 4, or else something is wrong somewhere. So it says minimum of p of x is 20 degrees Fahrenheit when you round it up. Minimum of p of x, oh no, it's 66 when you round it up. So the one that's not correct is option 4. So that is the answer for question number 15. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about what we just covered in this presentation, just place it in the comment section below, and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other tutorials such as this. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day. Goodbye.